This is a general review of factoring. We're going to first start off with a summary of rules, and then we will go through several examples. So first, when you're factoring, you should always first try to factor out a GCF, a greatest common factor. Next, if you have a binomial, two terms, check if it's a difference of squares. So does it fit the form a squared minus b squared? If it does, it factors to a plus b times a minus b. If you have a trinomial, three terms, check if it's a perfect square. So if it's of the form a squared plus 2ab plus b squared, it factors to a plus b quantity squared. If it's a squared minus 2ab plus b squared, it factors to a minus b quantity squared. Next, if it's a trinomial of the form x squared plus bx plus c, then use the sum and product method. That's summarized here, but when we get to the actual examples, it will look easier than it actually seems right now. Lastly, if it's a trinomial of the form ax squared plus bx plus c, where a does not equal 1, then you can factor it using several different methods, including the box method, splitting the x term, or trial and error. We're going to look at the box method. So first, let's look at a difference of two squares. Okay, again, that formula is a squared minus b squared is equal to a plus b times a minus b. So for example, 36x squared minus 25z squared. We have a perfect square, minus in between. So set up two sets of parentheses, take the square root of the first term, 6x, and write it at the beginning of both sets of parentheses, and then take the square root of the second term, 5z, and also add it to the parentheses. Now one parenthesis gets a plus, the other one gets a minus, and we're done. So the first example factored to 6x plus 5z times 6x minus 5z. Example 2, 4x squared minus 16. So remember, whenever you're factoring, the first thing you really should always do is check for a greatest common factor. Here we have one. It's 4, because 4 goes into both 4x squared and 16. So write down the GCF, write down your parentheses. 4x squared divided by 4 is x squared. 16 divided by 4 is 4, so it factors to 4 times x squared minus 4. Now we're going to look at what's in parentheses, and this looks like a difference of squares. We've got a perfect square, minus in between. So keep your GCF, write two sets of parentheses, take the square root of the first term, which is x, take the square root of the second term, which is 2. One gets a plus, one gets a minus. So example 2 factors to 4 times x plus 2 times x minus 2. Example 3, negative 6x cubed plus 24x. Is there a GCF? Yes, looks like 6x. And because the first term is negative, we usually include that negative with the GCF. So we're going to make the GCF negative 6x. Write down your GCF, write down your parentheses. Negative 6x cubed divided by negative 6x is x squared. 24x divided by negative 6x is minus 4. Again, let's look at what's in parentheses. We have a perfect square, minus in between. Write down your original GCF. Write down two sets of parentheses. Take the square root of the first term, so x. Take the square root of the second term, which is 2. Fill in the box. One gets a plus, one gets a minus. Sorry, that was fill in the parentheses. Okay, so example 3 is negative 6x times x plus 2 times x minus 2. Okay, thirdly, let's look at perfect squares, and we'll look at the formulas. So as we saw in the summary, these are the two formulas for factoring a perfect square trinomials. Let's look at how to use them. So for example, if we have 8x squared plus, if we have x squared plus 8x plus 16, we have a perfect square and a perfect square. So this leads to our possibly using the formulas. We're going to try to. We're going to set up a single set of parentheses with a squared. We're going to take the square root of the first term, which is x, the square root of the last term, which is 4. The middle term is positive, so we'll put a plus in our parentheses. Now to check this, we need to make sure that 2 times the first term times the last term, or 2 times x times 4, is going to equal the middle term of our original expression. So does 8x equal our middle term? Yes. That means this is the true factorization. It's x plus 4 quantity squared. Okay. Example 2. 4x squared minus 20xy plus 25y squared. Okay, this is a perfect square. Perfect square. Let's set up one set of parentheses with a squared. Square root of the first is 2x. Square root of the last is 5y. The middle term is negative, so we're going to put a minus. And now we're going to check it by doing 2 times 2x times negative 5y, which is negative 20xy, which is what we had to begin with in the middle of our of our original expression. That means this truly does factor to 2x minus 5y quantity squared. Let's look at a third example. Negative 18x cubed plus 12x squared minus 2x. Is there a GCF? Yes, it's 2x, and because the first term is negative, we'll actually make the GCF negative 2x. Write down your GCF, write down your parentheses. Negative 18x cubed divided by negative 2x is 9x squared. 12x squared divided by negative 2x is negative 6x. Negative 2x divided by negative 2x is plus 1. Looking at what's in parentheses, we have a perfect square and a perfect square, so let's try to factor this as a perfect square trinomial. Let's write our GCF. One set of parentheses squared. Let's take the square root of the first term, which is 3x. Square root of the last term, which is 1. Middle term is a negative term, so let's put a minus. And check this by doing 2 times 3x times 1, or negative 1, which is 6x, or negative 6x. And that equals the middle term in my parentheses. Okay. Looking at factoring trinomials, specifically of the form ax squared plus bx plus c, where a is equal to 1. In other words, there's no number in front of the x squared plus bx plus c. We're going to use what I've seen called the sum and product method. So for example, x squared plus 5x plus 6. 5 is in my B spot, 6 is in my C spot. We're going to first list factor pairs of C. Okay, to make a positive 6, we can do that by doing positive 1 times positive 6, negative 1 times negative 6, positive 2 times positive 3, Negative 2 times negative 3. Positive 3 times positive 2. Oh, but wait, we already really have that pair. We just have it in a different order. Okay, so we can erase that. And that means that all four of these are our only factor pairs. Next, find the pair that adds up to b. So b is 5. So first pair adds up to 7, negative 7, positive 5, negative 5. So that third pair adds up to what we need. Okay, fill that factor pair into the parentheses. So we're going to set up two sets of parentheses, put the square root of x squared in both of them, so x's, and then take our plus 2, plus 3, and fill in the parentheses. One gets a plus 2, one gets a plus 3. We could check these, any factoring, by expanding. So steps 1 and 2 I'll often summarize by just saying, find factors of c that add up to b. Okay, let's look at a second example. X squared minus 5x minus 2. Minus 24. Okay, I'm setting up the two sets of parentheses, filling in my x's at the beginning. C is negative 24, so positive 1, negative 24, negative 1, positive 24. Positive 2, negative 12, negative 2, positive 12. Positive 3, negative 8, negative 3, positive 8. Positive 4, negative 6, negative 4, positive 6. Okay, then we're going to find the pair that adds up to our middle term, to negative 5. Okay, first pair adds up to negative 23, positive 23. Negative 10, positive 10. Negative 5, and that's what we're looking for. So we have positive 3 and minus 8. We're going to fill those into our parentheses. So x plus 3, x minus 8, and we're done. Let's look at a third example. 2x squared plus 6x plus 4. First, factor out a GCF. What goes into 2, 6, and 4? 2 does. Write down our greatest common factor, then the parenthesis. 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. 4 divided by 2 is 2. Now we're going to look at what's in the parentheses, because that fits the model that we're using, where there's no term in front of the x squared. Here, our c is 2. So let's list factor pairs of 2. We've got plus 1, plus 2, negative 1, negative 2. And those are our only two factor pairs. We need the ones that add up to our b, which is 3. First pair adds up to positive 3, second pair is negative 3. So we want the first pair. So I keep the GCF, write two sets of parentheses, start by filling in the x's, and then add in the plus 1 and plus 2. So example 3 factors to 2 times x plus 1 times x plus 2. Okay, don't forget, always look for our GCF first. Okay, factoring ax squared plus bx plus c, where a does not equal 1. And I'm going to show the box method. So for example, 10x squared plus 11x minus 6. So our first step is to create a 2 by 2 box, like this. Then, in the top left box, put the first term, And in the bottom right box, put the last term. Okay, so 10x squared minus 6. Step 3 is to multiply those two terms. And we'll get here negative 60x squared. Then find two factors of negative 60x squared that add up to the middle term, which is 11x. And then we're going to put those factors in the empty boxes. So to make a negative 60x squared, I could have positive 1x times negative 60x, negative 1x times positive 60x, positive 2 times negative 30x, oops, I forgot the x, we'll fill that in a minute, negative 2x plus 30x, positive 3x times negative 20x, negative 3x times positive 20x, positive 4x times negative 15x, negative 4x plus 15 times positive 15x. And this is going to be the pair that adds up to our positive 11. So I have negative 4x, positive 15x. Those are those x's that I forgot to write, sorry. Okay, step 4. Factor a GCF, greatest common factor, out of the terms in each row and in each column. So if I look in the first row, what's the greatest common factor? Okay, 10 and 15, I can write 5. Both terms include an x, so I write x, and the x gets the lowest exponent, which is an invisible one. So our GCF is 5x in the first row. Second row, okay, negative 4 and negative 6, we can take out a 2. Whenever that left term is negative, I'm going to make that GCF negative. So our GCF is negative 2. First column, 10x squared, negative 4x, the GCF is 2x. Second column, 15x and negative 6, GCF is 3. Okay, step 5, the sum of the GCFs for the columns and rows are the factors. That means 5x plus negative 2, or 5x minus 2, times 2x plus 3. That's my factorization. So 10x squared plus 11x minus 6 factors to 5x minus 2 times 2x plus 3. Let's look at a second example. 3x squared minus 19x plus 6. Draw the box. Put 3x squared in the top left, plus 6 in the bottom right. Multiply the two, and I get 18x squared. We need factors of 18x squared that add up to negative 19x. So positive 1x, positive 18x. Negative 1x, negative 18x. And the second pair already adds up to what we need. So put one of them into the top empty box, negative 1x, and then the other one, negative 18x, into the bottom empty box. Again, it doesn't matter which box you put which term in. Let's factor our GCF out of the first row, and it's x. Out of the second row, and it's negative 6. Remember, because that left term is negative, the GCF is negative. Looking at the first column, GCF is 3x. Second column, it's negative 1. My factorization is x minus 6 times 3x minus 1. Okay, so quick practice. Try factoring 12x squared plus 5x minus 2. Pause this and then check your answer. You should have factored it to 3x plus 2 times 4x minus 1.